N7-4, exponential function, base e. Number 1 tells us to determine what happens to 1 plus 1 over n to the nth power as n approaches infinity. So I have typed into my calculator in the y equals screen 1 plus 1 over x to the x power, and I have set my window for my x values from 0 to a million here. Notice I've only set the y min and max from 0 to 5. When I graph this, it looks like pretty much a horizontal line, and it's pretty close to that. Not exactly, but pretty close. So to plug in values here, I'm going to hit second trace. Number 1 says value. I'm going to start by putting in x equals 1, press enter. I get y equals 2. If I put x equals 2, I'm going to press 2, press enter. I get 2.25. So 2.25. I press 5, I get 2.4883. I'm just going to round here to 4 decimals for a while. Okay. So as n approaches infinity, 1 plus 1 over n to the nth power approaches approximately 2.71828. And there's going to be some other numbers there, and we call this number e. As I was saying, we call this number e. Down below we have a little bit of an explanation. The number e is an irrational number defined as the number that the quantity 1 plus 1 over n to the nth power approaches as n approaches infinity. E occurs so often in applications it is often referred to as the exponential function, rounded to 3 decimal places, which is usually, we don't really need it to be usually more accurate than that. E is approximately 2.718. Turning to the back, we have graph f of x equals e to the x power. So I've put this into my calculator. I've gone to just a standard window from -10 to +10 for both my y and x, and so when I graph that, this is my graph. I'm going to get the values for my table here off the table. So I hit second, graph, which will take me to the table. And since I know that e is between 2 and 3, I know I can't go really beyond 2 here for my positive values. If I put in -1, it looks like I have my y value is 0.367. So we're going to round that. That's the same as saying 1 over e, but that's about 0.4. And really 1/10. 1 decimal place will be good here because I can't be more accurate than that on my graph. At 0, I get e itself. I mean, actually, if I put it e to the 0 power, anything to the 0 power is 1. It's my only super accurate thing. This will be e to the first when I put in 1, and that is approximately 2.7. And if I do e squared, that's going to be approximately 7.4. So let's graph those. At -1, I'm at about 0.4, 0, 1, 1, 2.7 or so, 2, 7.4. So it's going to be hugging the x-axis coming along, and then it's going to turn up pretty quickly here. My domain will be all real numbers. My range, y greater than 0. Asymptote at y equals 0. Characteristics. Well, it's a 1-to-1 function, like all exponentials. It's 1-to-1. It is increasing over its entire life. I have no x-intercepts. Realize you can't see all this stuff that I'm drawing here. And I have a y-intercept of 0, 1. And there's my graph that you could not see me draw a minute ago. Sorry about that. Okay. Number 2, we're now graphing transformations of e to the x power. So this one has negative e to the x power plus 5. So the negative on the base tells me x-axis reflection. Negative on the exponent tells me a y-axis reflection. The plus 5 that is being added to my base with the exponent means we'll shift up 5. All right. So I know that instead of being y greater than 0, it will be 1, 2, 3, 4, and we'll have an asymptote at y equals 5. If I make my little table here with x and e to the x, negative 1, remember, is approximately 0.4, 0, 1, 1, 2.7, 2, 7.4. So each of these, let me sketch them in very lightly here. Here, 1 is 2.7, 2 is 7.4, about right there. All right, so let's start with negative 1.4. I do an x-axis reflection, so it's going to go, instead of being 0.4 above, it'll be 0.4 below, and then we'll shift it up 5. 1, 2, 3, 4, 5 would be about right here. 0, 1, it's 1 above, I'm going to reflect it 1 below, shift it up 5, 1, 2, 3, 4, excuse me, 1, 2, 3, 4, 5, so that's at 0, 4. 2.7, I'm going to reflect it down 2.7 below the x-axis, and then go up 5. 1, 2, 3, 4, 5. So it ends up being really close, just below where it was before. And then 7.4, I'm reflecting it down. It's negative 7.4, which would be here. And then 5 up. 1, 2, 3, 4, 5. Be about right here. So my graph is hugging this asymptote, and then it's going to turn sharply down. My domain is all real numbers. My range is y less than 5, and my asymptote is y equals 5. Number 3 says f of x equals e to the 4 minus x power plus 1. So I want to rewrite this exponent so it has, like, in terms of a positive x. So I'm going to factor a negative out. And if I factor that negative out, I'll have a positive x minus 4. Because if I distribute the negative, negative x gives me this minus x. A negative of minus 4 gives me that positive 4 plus 1 behind. So what this is doing is the negative on the exponent gives me a y-axis reflection. The minus 4 inside the parentheses there, usually minus 4 would mean 4 to the left, so this is going to go 4 right. Does the opposite of what we expect when we have that shift in the exponent. And then the plus 1 down behind means 1 up. So I'm going to have an asymptote, 1 above y equals 0, which is going to be y equals 1. Once again, I can make my little table here with x and f of x, negative 1, 0, 1, 2. Remember it was 0.4, 1, 2.7, 7.4. So let's plot those points very lightly here. Negative 1 is 0.4, 0, 1, 2.7, and 6, 7.4. So y-axis reflection, I'm going to go from negative 1.4 to positive 1.4. I'm going to go 4 to the right, 1, 2, 3, 4, and then I'm going to go 1 up. 1, 2, 3, 4, 1 up puts me at approximately 5, 1.4. 0, 1, I'm not going to, the y-axis reflection does not reflect that since it's on the y-axis. I go 4 to the right, 1, 2, 3, 4, 1 up, should be exactly at 4, 2. 1, 2.7, I go across the y-axis to negative 1, 2.7, and now I go 4 to the right, 1, 2, 3, 4, and 1 up. So it's at approximately 3, 3.7. And then 7.4 is 2 to the right. I'm going to go 7.4 up and 2 to the left. 4 to the right now, 1, 2, 3, 4. Puts me exactly where I started, and then 1 up. Right here. And now I just draw my smooth curve that connects all these points and then follows my asymptote as I move to the right. There we go. My domain for this, all real numbers. My range, y greater than 1, never going to go below that asymptote. And my asymptote, y equals 1. There you go.